.NET 8 and Architecture with Steve Smith.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast and deliver quality and to run your software with confidence in Azure, all while using absolutely everything that the .NET ecosystem has to offer. The podcast is sponsored by ClearMeasure, a full-service software engineering firm empowering software delivery for business-critical software projects. Quick announcement, my architect forums are going really strong. Signups for the next session are up, and if you lead a software team and are just looking for peers to collaborate with out there in the industry, then you can just go ahead and sign up at the link in the show notes. We know there's all kinds of content out there for developers and people looking to code, but not so much for people looking to lead groups of people who code. So this is just a free avenue to collaborate with peers. So I encourage you if you're interested. And for those looking for Programming with Palermo, my video show, then just search for it in any of the directories and you'll be able to find it. Well, my returning guest on the show is Steve Smith. He's been on the show 2 other times, most recently in episode 205, I believe. We'll include a link in the show notes. He was talking about domain-driven design and clean architecture. But Steve works with companies that want to avoid the trap of technical debt by helping their teams deliver quality software quickly. He and his team at NimblePros have been described by clients as a force multiplier, amplifying the value of existing development teams. And his client list includes Microsoft, Quicken Loans, Celina Insurance, and a lot of other satisfied customers. And he also offers career coaching to developers through devbetter.com. And he's also been recognized as a Microsoft MVP, Most Valuable Professional, for over 20 years. That's pretty much as long as .NET has been out. So, Steve, welcome back to the show. How are you, sir?
I'm doing great, Jeffrey. How are you?
I'm good. Christmas is upon us here in 2023. It's exciting. Getting one last podcast recording in for that happens. But we just finished .NET Conf just a few weeks ago, and you gave a talk on clean architecture there. And so I want to ask you kind of all about .NET 8 and everything. But before I dig in and ask you, I think you're right on the cusp. You're kind of one of the old timers now of .NET development and seeing everything. Let's back up a little bit for the listeners who haven't really seen any of your talks or heard you teach on any of the topics. Can you pinpoint like a few of the big events in your career that have kind of led you along the path and working on the types of things you're working on today?
Sure. That's a big topic. But yeah, I mean, I got into .NET in the early days. I was fortunate enough to be part of a group that was kind of beta testing the new, what would become ASP.NET. It was called ASP Plus at the time and was announced in 2002, but we were playing with it in 2001. And eventually that became what we call web forms today, but it was really groundbreaking at the time, and it involved new tools. Everything was much more object-oriented because before that we had VB6 and ASP with VBScript, and there was not a lot of proper object-oriented principles that you could really use there. And so this was the first time that you could do that. And there was this brand new cool language called C# that no one had ever used before, that was just created for .NET. And I really loved that and got into it then. And started down that path and had my own company, did some training, had an advertising company, built my own product, which was an ad server, and hired some people, and we built something that ran millions of ads every month for a bunch of different developer websites. Eventually we sold that business, and things grew. And so I really got to experience both as a trainer how to really work with this system, the new .NET framework and the later versions, as well as a business owner and as a product developer, right? What were some of the pain points in trying to extend it and trying to maintain it? And along that journey, I started to really value automated tests. and continuous integration. And, some of the tenets of agile software development really made sense to me. It's like, well, why should we pay an expensive developer to do manual testing over and over again every time they change something? Aren't computers really good at that? Aren't they even better than humans at doing the same thing over and over again quickly? And so really figuring out a way to write testable software became a passion of mine, because writing software that I was trying to test in an automated fashion, but it was really tightly coupled to the database because the patterns, I hadn't learned the patterns yet to avoid that. I really felt that pain. And so I learned the techniques and the patterns to overcome that. Got involved in Pluralsight in the early days and did a lot of training there on solid principles and design patterns, and shared some of the things I learned along the way. Domain-driven design was another one that really resonated with me, and it was kind of the same idea. It was like, let's focus on the complexity of the system, of the business problem, and not be tightly coupled to the particular infrastructure that we're using at the moment, this particular database or this particular file system. Right? Those are sort of afterthoughts, and we can wire up our system to whichever one of those makes sense at the moment. And with the cloud really coming onto the scene, and Docker and containerization and virtualization all coming along, right, all that made more and more sense and really paid dividends, because people really were shifting, like, oh, we're not going to have our own server all the time. We might want to plug in a different provider for email sending, or we might want to use a different adapter for this particular type of data or that particular log or something like that. So, it really just all made sense. And the way the industry went with that, where, microservices are now a big thing, and domain-driven design really fits well with the design of microservices. So I've been fortunate that the patterns that I've learned have become increasingly valuable in my career and in the industry at large.
Yeah, for sure. You're doing so many things over the last number of decades. You look at the .NET 8 release with different lens than people who are maybe in their first 5 years of programming in their career. And so when you look at .NET 8, and there's just tons of stuff that were talked about, and tons of stuff on the .NET Conf, YouTube channel and all the different sessions, which parts of the .NET 8 release really stood out for you, thinking, okay, I need to dig into this. This is going to be big. This is going to be interesting. Not just another library enhancement or, oh, that's nice, but something like, whoa, that's really interesting.
Yeah, I would say probably the biggest thing for me on that front would be the .NET Aspire stuff. I don't know if you've had a chance to really look at that, but that was pretty much just initially launched and shared with the public at .NET Conf last month. And it's not ready yet. I mean, it's still in preview, but it's really pretty exciting stuff there, where there's a lot better integration with open telemetry, and not just where they're providing the hooks, which we've had in the framework for a while, but also providing you with samples and templates and things that will let you capture that telemetry and view it in a really compelling way, and be able to see like a request that goes through several different microservices along the way, be able to trace that request in a graphical way inside of your application using open source tools that support open telemetry and stuff. Like, I think a lot of teams are going to be using that 6 or 12 months from now.
Yeah, and I think they said that they were going to try to go GA with it sometime in 2024, although we don't really know, right? That's the latest information they announced.
Right.
Yeah.
But even if they don't get it, make it that quickly, I think just the fact that they're moving in that direction, a lot of developers are going to see that that's a thing that they should be doing and they could be doing, and stakeholders are going to be asking for that kind of thing. So even if .NET Aspire itself doesn't come out as like the standard way, which I'm sure eventually it will, they're leveraging other open source tools like Grafana and Prometheus and things like that already work with the open telemetry system. And so I think a lot of teams will just start moving that direction, even if .NET Aspire isn't there yet, and then probably will adopt .NET Aspire once those templates and things become fully baked.
Yeah. One of the things when I listened to the announcement they made as well, and I, just a couple weeks ago, we had Scott Hunter as a guest on the show, and he was talking about Aspire, and really excited. They've done tons of work on it, but an underlying assumption, which the developer division has tended to try to not be as opinionated and just giving like 4 or 5 different ways. Well, you could do it this way, but it seems like they're really getting opinionated in one factor that stood out. I want to get your opinion on that. And that is the assumption of every running process in your software that you build in this way is going to be hosted in a Linux container. That seems to be an underlying assumption of .NET Aspire. Did you get the same view?
I think there's an assumption that .NET Core apps should be runnable in a Linux container.
Mm-hmm.
Not that they have to be run there, but that's been a thing for .NET Core from day one is that it's cross-platform, and the Linux containers have historically been smaller, cheaper, faster than the equivalent Windows containers. So, if you're looking to move to the cloud, you're trying to minimize resource costs, whether you're Microsoft, who's hosting those containers, or a customer that's having to pay those hosting costs to get passed down to you, it just makes sense to use those Linux containers in many scenarios.
Yeah. Well, I picked up on that because up until this point, it seems like Azure App Service has been like one of the more normal places to host it. And that's on a full Windows Server instance where you get a slice of the server, or you can put multiple on there. But now with Aspire, kind of the assumption is, well, now Azure Container Apps, they're really saying, okay, no, let's steer you towards Azure Container Apps. And that seems to be a notable shift in guidance.
Right. Yeah. No, I agree. I think you can use Azure App Service on Linux as well if you want, but in that case, it's still not containerized. Whereas kind of moving toward container-based development by default, I think is a logical move, but one that they're definitely shifting more toward.
Yeah.
And they kind of pushed for that with Dapr, DAPR, not the data access technology, as well. And so, that's, also kind of been, that goes as a sidecar container, is the way that's deployed. So, it sort of assumes that you're doing a containerized app as well.
Right. I did watch do a plug for your clean architecture video at .NET Conf, which we'll make sure to include a link in the show notes to that recording on YouTube. But besides just the patterns, you push for having a good, complete build that can run on a developer's workstation that makes sure that the various dependencies are set up and wired together. And with Aspire, or with .NET Aspire, it seems like some of the dependencies that haven't been as easy to run in an automatic way on a local developer's workstation are going to be more easy. Did you get that sense as well?
Yeah, I'm not sure if we'll get there like fully with some of these things, but I think that is the goal for sure. Some of the Azure cloud-based tooling, Microsoft's gone in two different directions here. One, they're trying to make it easier to run everything locally on your machine, which Docker helps with tremendously because you can pull a lot of these things in as Docker images, either to act as a fake version of the one you'll use in production, or even as like the real thing, but running locally. And they do have some gaps there still. Like I've been waiting for a long time for Azure Service Bus to have a local emulation version, and they still don't have that. But on the other end, Microsoft's making it easier and easier for your development environment or your test environment, if you prefer, to run in a dev container that's hosted on Azure. And of course, being in the business of charging folks for using their Azure resources, Microsoft would love for every developer to have their development environment in the cloud. But it does have some wins there in terms of being able to wire up to the dependencies that are already there in the cloud where your app is going to run.
Yeah, for sure. In your lead up, you mentioned testing and quality multiple times, and there's a lot of things that come out with .NET 8 and lots of stuff with Blazor in the cloud, and like you mentioned, .NET Aspire. But for the younger developers who are looking at new tech coming out, what's your thought on the state of test automation and what level developers should really make sure that they have, just to have a foundational element where they know they're not missing out?
I think developers should be capable of writing and comfortable writing unit tests for their software. And ideally, they should be able to write unit-testable code, which is its own skill, and not one that I had when I graduated from university. It wasn't until several years later that I learned this is the way I have to write my code for it to be unit-testable. And a lot of that comes down to dependency management. And .NET Framework did not have dependency injection as a principle of how it was designed. .NET Core, .NET 8 does, right? So that's a huge shift where it's just expected that dependency injection is how you're going to build your software. Now, there's still plenty of ways that you can do that wrong, and places where you can just have static dependencies or new up something with a out-of-process dependency anywhere you want. you don't have to do that, and you're not really supposed to do that, right? And they sort of make it easy to fall into the pit of success by using dependency injection appropriately. And so if you're a new developer and you're not comfortable with dependency injection, I would learn about that. Mark Seaman has an excellent book about DI that I would strongly recommend. It's not just about DI; it's really about writing quality software. And so, check that book out. It's Dependency Injection, something, second edition. And solid principles are covered well in that book. I also have a course on it on Pluralsight, plenty of content online for that as well. So learn those, especially dependency inversion principle, because that's what really is key to making your software testable, is getting those dependencies on out-of-process concerns to be at arm's length from your code.
Yeah. And you mentioned that a lot in your clean architecture training and talks. And
I do.
C# developers are taught, oh, here's an interface. Here's how to make a class implement the interface. In general, do you see code bases that you like have lots of interfaces with one implementation, or are there scenarios where you want to have multiple implementations of the interface? And how do you think about that? And how should young developers know how to sort out that dynamic when they're trying to add a level of indirection or trying to decouple something?
Sure. Yeah, something I've only recently started to hone in on as a terminology for that I think is valuable is the idea that when you think about the name of an interface, that interface is describing what you as the caller of that interface, what you need from something, right? So the interface, when you name it, when you describe the methods on it, it's saying what it's going to do. And then the implementation is all about how, right? So as long as you can break it down around those two questions, and so the interface shouldn't reveal anything about how. It should only say what, right? So the what could be something like, I need to get this data, or I need to send an email, right? That's what needs to happen. Now, how am I going to do that? Well, I'm going to use a SQL Server database to go and write a select query to get the data, or I'm going to go read it from an XML file, or I'm going to send this email using a local SMTP server, or I'm going to use a service like SendGrid, right? That's how. And for each how, you're going to have a different implementation. Now, whether this or that application needs to have multiple different ways of doing something concurrently at the same time in production, right? A lot of applications won't. But it might be that it's useful to have more than one implementation in different environments. It might be that on your local dev machine, it's nice to have a different way to do some of these things. Like you don't really want to send emails usually from your local dev machine, but it might be nice to have those emails logged to a text file that you could look at as a developer. And that might be true in your stage environment too. So a lot of the times the environments determine which set of dependencies you want to use and which of these different patterns or implementations rather you want to use for each one of those interfaces.
Yeah, I like that way of explaining it. Yeah, that's a cool, concise way to give guidance in that. It's almost like you've had some practice explaining it.
Once or twice.
Right. So back to the .NET 8 release, are there any other things where you've put it on your list and you want to spend more time with it, things that are notable?
There's some new stuff coming in the language in C# 12, which I like. There's C# primary constructors, which is basically taking the syntax that we've had on records for a little while now, where you can add some parentheses after the class name. But we're applying it now to classes, and it's basically taking the place of a constructor where you don't necessarily have to have that extra 4 or 5 or however many lines of code to define explicitly a constructor that takes in certain arguments that class needs. Now, there's a little bit of weirdness and maybe perhaps immaturity still in the feature because these parameters, the scope in which you can access them is the entire class, right? From any field, you can assign and initialize something from one of these parameters, which is the place that you should be using them. But you can also use them in any method. And you can't just read the values. You can also write the values, right? So you might have a class that you initialize with a class level default parameter. And then in one method, you can reset that value to something else or set it to null. And then some other method tries to access it also. And depending on the order in which you call the methods, that parameter's value could change. There's no way to set it as read-only. So my guidance is to only use those to initialize fields, use read-only fields where it makes sense, which is going to be most of the time. And then within the rest of your methods, just use those fields like you always have. But it is a nice way to save a few lines of code, especially when you have a lot of classes that use dependency injection, and they all take in 2 or 3 different things in a constructor. And so you've got 6 lines of code of constructor glue that is just plumbing. You can get rid of most of that by putting it all on the first line with the class definition.
Many thanks to our podcast sponsor, ClearMeasure. ClearMeasure is a software architecture company that empowers clients' development teams to be self-sufficient, moving fast, delivering quality, and running their systems with confidence. Whether starting a new project or developing new technologies or techniques, ClearMeasure sets up your team to deliver world-class results. Learn more at www.clearmeasure.com. ClearMeasure, empowering software delivery.
ClearMeasure is also happy to be a sponsor of the video podcast, Programming with Palermo. Watch, learn, and program alongside Chief Architect Jeffrey Palermo. Videos are added weekly and available on syndicated locations supporting video podcast or by visiting palermo.network. Tune in today.
Does it simply compile down to a private field?
It doesn't. And you can see that behind the scenes, it kind of does, but not until after compilation, right? So at development time, when you type this dot, you're not going to see anything there, right? There's not a field that is that thing. Now, when it makes it to the CLR, I believe that is the implementation. It is like a hidden field that's there. And so at runtime and reflection, you could probably get to it there. But inside your code, it is different from a field in that if you're used to using this dot to get to those local fields, you won't see those parameters there. They are, in fact, just parameters, not fields. And that ties into the naming too. So if you're used to using like underscore whatever for your private fields, which I recommend, I prefer that convention. I don't use that, or I don't recommend that for these class level parameters. They should be named pretty much just like a parameter, just like you would have used on your constructor.
Camel case.
Exactly. Yeah.
Okay. So they're in scope for every method, just like a method parameter would be.
Right. It's exactly like if you took your existing constructors that we've always had in C# and you take the arguments, their parameters that are coming into those, but you just said, hey, that scope of that argument, let's make it so you can get to it anywhere in the entire class.
That's a whole new concept.
Which is weird. Yeah, it is. It's a whole new thing. Like I'm used to there being scope of parameters, which are inside of some curly braces inside of a method.
Yeah.
And then there's private and protected and public. Like those are the things. That's all there are. Like you have to find a new spot in your brain for like, here's this parameter that isn't bounded by the curly braces of a method. It's bounded by the curly braces of the class, which is just different.
Is the official name class parameters?
Primary constructors is what they're called. And then I believe, I think they're called class parameters. That's what I've been calling them.
Yeah, because we can't call them fields then.
Constructor has these parameters on it. And they're not fields.
They're not fields.
They're not members.
They're not members. Yeah, this is a whole new thing that we're going to have very precise, just like domain-driven design. We have to have a precise term added to the language so that we don't get confused on what it is.
Right. And I think they're called class level parameters. That's what I have in my head. But if I check the docs, it might be slightly off.
Yeah. Well, I mean, even me and you have been coding for a long time. We're just going to have to figure out where this fits and where it doesn't quite work. Because at first, like when records came out, I was thinking, oh, are we gonna make our our entities that are aggregate roots and persisted classes? Are we just gonna make those records now? It's like, well, no, I actually didn't end up doing that. I kept those as classes most of the time.
Right. Yep. Same.
But it's like, okay, plain Jane vanilla DTOs, I tended to make them records.
Yep. Exactly. And now more recently, I think what was it, C#11? We have record struct. So if you wanted to not have as many allocations, you can use them as structs, so they're just passed around on the stack, which is maybe more efficient in some scenarios.
Now, for most business applications, have you had that be a thought process of, okay, this is a scenario I really want to use record struct now?
Not typically, but it is easy with benchmark.net to do quick checks for things like that. Most of the time, it's not going to make a difference in business software, which has a fairly small number of users for internal purposes. But it's one of those things where if you know that it's an option, you can at least keep it in mind and consider it. And in cases where it's in like a tight loop, sometimes it makes a difference. We have a lot of customers where they are writing business software, but even with their low number of users, they might have a large number of records of data. And so when you have some kind of batch processing task, right? The allocations there can add up and take, something that, takes 8 or 9 hours to run. If you can get some things off of the heap and reduce the number of allocations and garbage collections, right, you can shrink that down to be like, 10 minutes or something, right?
Yeah.
With numerous different types of optimizations.
Yeah, that's a good point. If the code is going to run on a tiny little system on a chip with limited memory and you don't want to be doing garbage collection, okay, let's try to keep stuff off the heap. And for younger developers, even knowing there is a stack and a heap and what the heck those are and how processors use them,
right,
that's important. But if I'm in software where I'm doing even one database call or one across network web service, then that's going to make every other little tiny micro pale in comparison to the order of magnitude more time I'm taking to jump across the network.
For sure.
I think that's why it doesn't make a difference for most business applications, right?
Yeah, anything that's IO driven, that's where you're going to get the biggest bang for your buck. So when I'm first looking at performance improvements for a business, usually the very first thing I'm looking for is caching, because there's so often you're asking for the same data over and over again from the database, and so implementing a cache is a cheap and easy win that gives you orders of magnitude performance boosts. And then the second one after that is going to be indexes on the database. And between those two, you usually can get the biggest gains really quickly on most systems.
Yeah.
Optimizing for memory allocations is pretty far down the list, and it's only if it's something that's running in a tight loop or running for every request for millions of calls that it's going to add up.
Yeah. Speaking of architecture and web services and jumping across the wire, with clean architecture and managing dependencies, I think there's really good and stable guidance for how to structure a Visual Studio solution and projects and project references. But what is your go-to? How do you think about the distributed system when you're going to have let's say 5 different processes that are going to be deployed, and they're all kind of coordinating in some way, and they're passing, they're using some shared data, but then they're calling each other. And of course, out there in the wild, you have process A calling web service to process B, or process A dropping a durable message on Azure Service Bus where B picks it up. And so when you think about managing dependencies and that structure of a distributed system, how do you teach that, since you do it all a lot of times?
Yeah, I mean, the first rule of building distributed systems is don't, unless you have a really good reason to, because it adds a ton of complexity to the system. So if you can make do with a monolith, do that. And even if you're going to need a distributed system, it's often better to just build a monolith first and then start to peel off those external services. That's what Martin Fowler has recommended for at least a decade, I think, when he first published an article about it. And it served me well also. And I've been involved in projects where they tried to build this big greenfield microservice everything structure, and things did not go well. I mean, it took a long time, and there was a lot of churn in terms of how things were structured and how things moved around. And when you want to refactor something in a local app, right, sometimes that takes some effort, but it's still all just right there. It's all code that you can just compile and change and run unit tests on. Mm-hmm. When you want to refactor a microservices distributed application, it goes across many different teams. It takes weeks or months, numbers of sprints to do any meaningful refactoring in a lot of cases. And so things can get a lot slower. So oftentimes it's better to get it stable first. In terms of dependency management, I talk a lot about CAP theorem and a related principle called PACELC, PACELC. And CAP theorem basically relates to microservices and says that you can have consistency or availability in the presence of a fault tolerance, but you can't have both. Or sorry, mm-hmm. in the presence of a partition, not fault, partition. That's the P. So let's take a scenario where you've got service A that calls service B in order to do its job, right? Now mm-hmm. It's a synchronous call at runtime.
Yep.
So if service B is down, then service A has one of two choices. It can either return back an error and say, hey, I couldn't do my job. That other thing I need isn't there. Or it can return something that maybe has old data, right? Well, service B is down, but I've got this cache of what it had last time it was up. Mm-hmm. I'll send you that, right? That may not be right because, something may have changed over on service B in the meantime. So it may not be consistent, which is what I mean by right. but at least you're not down, right? You can say, I'm still available. I've just got an old version of the data. And so that's kind of the trade-off that you can make. And it's that would be for like a query where you're asking it for something typically. Similar would be with a command where, service A is executing some kind of command logic. It's making a mutation, maybe it's placing an order. And in order to do its job, it has to talk to service B. Same idea. If service B is down, it could just say, sorry, you can't place your order right now. Or if you introduce like a message queue, you could put the thing on the queue to say, hey, B, when you come back up, do your job, take this thing off the queue. And then A can report back to the user and say, success, we did the thing. Now, it's not consistent yet because it hasn't gone all the way through. B hasn't picked up that message, but you're still available, right? And so that's, again, the choice you make a lot of the time when you're building these distributed systems. And oftentimes you want to avoid having these real-time synchronous dependencies between those services for exactly that reason.
I like that. And my experiences tended to be very similar, that all the microservices hype architecturally, initially when I heard years ago when people were hyping it, it didn't architecturally make sense to me. And I'm like, okay, what am I missing? What am I missing? There's a lot of people pushing on this. And then, the hype cycle. And then I think we went boom, right to the bottom of the trough of disillusionment. And some of the, was it Uber was one of the companies where someone illustrated, wrote up like how it was a disastrous architecture and it didn't work. And then we figure out, okay, here's the sliver of innovation that's really, really valuable here. And I think that sliver was, if you have something that truly has an independent life, put it in a separate source control repository and give it a completely separate life, and then figure out how to make those two applications coordinate appropriately. That's how it sticks in my mind is, okay, what was the nugget of brilliance behind the whole microservices movement? Besides just, we've had durable messaging, we've had how to call, process A and process B. Those things have gotten easier. But is there another nugget of brilliance that you've pulled through all the conversations about microservices? I think that's the main
one. It's like, if this was something that you could have used a SaaS solution off the shelf for, and you would have integrated with it in the same way, where you've got, a subscriber key or something, and you're passing, back and forth to it through HTTP messages or message queue messages, whatever it might be. But it's at arm's length from you. It does not share your database. It's not even part of your company, right? It's certainly not part of your team. Then that is a reasonable way to think about microservices, right? If you want to be successful with them, is it's its own separate thing that has its own life cycle, deploys whenever they feel like deploying it. If you want to know how to work with it, you read their docs, and that's how you integrate with it. Does it make sense to have some type of abstraction layer between you and it? What DDD would call an anti-corruption layer? Absolutely, it does. Because if that thing changes, you don't want it to break your application, and so you want to have some type of a client through which you work with that thing. And maybe at some point you want to swap it out with something else, right? So some type of interface or adapters may make sense in many cases. Maybe you want to introduce a caching layer on your end that protects you from when that thing's down, or to improve the performance. Right? All those things make sense with a SaaS, software as a service thing that you're working with. They make sense with a microservice that you might integrate with inside your organization.
Yeah.
Amazon had the right idea when they started with S3 back in the day, and they started saying, we're going to build these things as separate services. And they put an edict out that said developers cannot integrate except through these services interfaces. Right. That was brilliant. That was 2006 or so. And that's what turned an online bookstore into one of the leading cloud providers.
Yeah. Because you could pivot. And how I think about it is each service or each system controlled its own communication channels. And I think in the .NET world, there's a few times where we thought, wait a minute, I don't want to publish an HTTP based communication channel, because what if I change my mind? How about I publish a little tiny C# .NET library and tell them to call it, and I'll ship them a little bit of code that calls me over HTTP, but gives me the power to update that little NuGet package on a private NuGet server if I want to change my entire communication protocol.
That's right. Yeah, ship your own client, and if you want to change it, from HTTP to something else, gRPC or whatever, down the road, you've got the flexibility to do that.
Yeah, and like rate limiting, like you mentioned, all kinds of stuff. You're in control. Well,
Yeah.
With microservices.
And that stuff's easy to do now with like NSWAG and Swagger and stuff. Like you can generate most of that client code. So there's not a lot of actual code you have to write.
Right. Now, microservices, I think, were on the slope of enlightenment for the Gartner hype curve, where you have the initial innovation and everybody gets excited, and then you hit the top peak of inflated expectations, and then you drop way down to the trough of disillusionment, and then we start creeping back up, and we're like, oh, this is how I should use this innovation. So let me pivot. I try not to overhype this myself, but let's end on the topic of the latest generation of artificial intelligence and the GPT era, because we're very much like racing to the top of the peak of inflated expectations. Some people who like early adopters, I've seen some early adopters have already hit that peak and are coming back down towards the disillusionment. What is your thought? Where do you think that we're going to come out of here on, okay, here's the nugget of brilliance that's going to change everything, and then what's just hype?
I think for developers, the AI story is pretty game changing, especially for new developers, right? Number of developers in the world has been doubling every 5 years for at least the last 20 years, pretty consistently, which means that half of all the developers in the world right now have less than 5 years of experience.
Yeah.
But ChatGPT is like Stack Overflow plus in terms of being able to quickly give you information about a problem that you're experiencing, right? Especially if it's about something that isn't just, last week, right? You're not going to ask it about .NET Aspire, right? But if you want to ask it like, well, how do I sort a list in C# in an efficient way, right? I can ask ChatGPT that, and it's going to give me a great answer. And I can say, well, how would I implement that in JavaScript? And it's like, oh, well, here you go. It's in JavaScript now, right? And then if I want to learn a new language, like, oh, how about Rust? Okay, boom, it'll translate it to whatever language I want. And I can be 95% confident that it's going to be right. And when it's not right, it'll correct itself. I can point it out and say, hey, I tried that and it fails on this line. It's like, oh, my bad. Here's what you need to do, right? And it's like talking to someone who's a fallible but mostly competent, partner that you're working with. And I think that really boosts developer productivity, or at least I've found it to boost that productivity. It also shines really well for documentation, for explaining code. If you have some really long method and you're not quite sure what it does, you could spend a couple hours looking at it and trying to figure it out, or you could copy paste it into ChatGPT and say, what the heck does this do? And it does a pretty good job usually of explaining it. So there's a lot of places for developer productivity where it's huge. I don't think that's where most businesses are excited, although many of them should be, because developers are expensive, and this is going to add to their productivity dramatically.
Yeah.
But I was just at a conference last week on AI, and there were a lot of developers there learning about how to build their own large language models, how to tune models to make them better, how to eliminate fabrications and where the AIs just make stuff up. Prompt engineering, that's going to be a thing. It already is, but we're going to have people whose title is like prompt engineer.
Right.
Like that's your skill, is knowing how to talk better to AI chatbots. But yeah, it's here to stay, and definitely on the ramp up to the hype cycle right now. I think a lot of businesses are trying to figure out where to plug into it, and they're going to try every which way they can, and we'll see which ones stick and succeed and which ones don't.
Yeah. Well, young people just historically have adopted new innovations faster. And I think some of the people coming down to the trough of disillusionment are college students. I hear more stories of professors adding to their tool belt the AI detectors and, paper submissions in college. Students are getting busted for just flat out generating an entire assignment. So they're definitely disillusioned with what they thought it could do for them.
And some of them are false positives too, right? Those detectors are totally fallible, right? And they're hitting folks that wrote all the code themselves or wrote the paper themselves too. I'm not sure how you would ever write one that is able to do its job in a perfect manner.
Yeah. Well, one thing that stands out to me is the old adage, garbage in, garbage out. Well, not necessarily garbage, but given that you have to train a large language model, you have to put data in. Well, somebody's got to choose what data goes in, right? And so if someone is choosing, well, that's an inherent focus. Now, in some areas, you might call it the bias, but it's just a choice, right? And so in code, you have lots of real code going in, and whereas in other fields, you may have information going in that's contradictory. Like people are still debating what the best way to treat diabetes is and how food interacts with it. Well, okay, if the dust hasn't settled and we haven't figured that out, how can you possibly have a database where you ask a large language model for the answer and it give it to you back, since the humans who are the experts in that field are still debating it?
Right. Yeah. I mean, at the end of the day, all these large language models is the ability to guess the next word, right? The next token. Right. And it's like on your phone, when you go to make a text, it'll give you like 3 or 4 words you can pick from and just start typing. And yeah, if you just keep picking those, it'll probably end up with something that doesn't even make any sense as your text. Right. But with a large language model, it's much more likely to come up with a whole paragraph or even a whole paper that is, something that mostly makes sense as you read it. And part of that's because they use probabilistic models for that. Mm-hmm. And that's also the reason why they don't give you the same thing when you ask it again, or if I ask it and then you ask it, we'll both get different answers. But they're both still, reasonably likely to exist as a logical, construct within the language, right? And I think that's important to understand that that's all it is, right? It's not really intelligent. It's not really someone on the other side, talking to you. It's just generating the next word and the next word and the next word based on a really large sample of essentially a mind map of saying these terms usually go together in this way. These are synonyms and these things group in other ways. And when someone sees this word and it was preceded by these words, probably the next one's going to be one of these. And I'm going to pick this one this time.
Yeah, that's interesting. It'll be interesting to see our world go along that hype cycle and where we come up from the trough of disillusionment when it kind of hits the masses, and how we pull away saying, all right, here's the lasting nugget that really changes the world.
Right. And to your point about inputs, I mean, that is a valid concern. And things like ChatGPT, which are just trained on the internet, mm-hmm. They're limited by the fact that they're only able to see public data. Whereas a lot of these companies, medical companies, research companies, they have a lot of internal documents and knowledge bases and things that are not public. And they can train or tune an existing model on those documents so that they're able to get much better responses from their AI than something that was just getting, it's putting equal weight on an academic paper and some forum that it picked up off of Reddit or, something like, which one's going to be better? Well, obviously the one that's using all of their internal research is more likely to generate a response that's consistent with their organizational knowledge base than something that's just trained on the internet.
Yeah. Well, that's a good point, because I've even interrogated a few of them about like books that have been published for decades, and it didn't seem to have knowledge of the contents of a book on the topic that I was asking about. I'm thinking, is it really trained on public opinions and just not even trained on published, multiple decades old books? I mean, it seems to
maybe it only was trained on the forum posts and reviews and not on the actual, source content itself.
Right. We'll see. Yeah. Lots of smart people are working on this problem. So we'll see how it shakes out.
Yeah. It'll be interesting to see for sure.
Well, Steve, thanks for coming back on the podcast. I really appreciate it. You were on September of 2022, so just over a year. We got you back, and we'll include all the links to the things we talked about in the show notes. And yeah, thanks for being with us today.
Yeah, you bet. It's great chatting with you. We'll talk to you again sometime next year. We'll see.
Absolutely. Absolutely. And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.